Hello everyone, I'm Huang, and my topic is Sleepease, an AI-integrated mobile and hardware system for personalized sleep monitoring and adaptive soundscapes. And I'm the presenter, and I'm glad to be here and share it with you. So, quick question at the start. Wait, okay. So, did you had a good sleep last night? Okay, actually, I didn't had a good sleep last night. I was so worried about today's presentation, and I went to bed at about 12 o'clock, but I didn't fall asleep until 1 o'clock. Yeah, so that's why I started this project. So for myself, I usually find it hard to fall asleep under great academic pressure since I'm currently a high school senior and yeah, I'm really busy with the college application. And for my friend, one of my friend had insomnia and she was suffer from depression and I really want to help her. And the third reason is that for the humanity, there are approximately one-third of American adults reporting fewer than 7 hours of sleep per night. Um, yeah. So as we all know, insomnia will result in many mental and physical sickness, and it will affect students' academic behavior and finally results in bad grades. So the target of my project is to improve human physical and mental health through addressing insomnia. But somebody might ask, well, there are already so many sleep aid product in the market, so why we choose Sleepease? How could Sleepease stand out? So the first reason is that Sleepease could recommend the most suitable white noise and ambient temperature for each specific user based on their user data. So as you can see on the screen, there's the recommendation page of the companion app. So my project has the companion app, the device, and the Firebase for the backup. So the recommendation page could show the recommended temperature and the white noise for the user. But yeah, so how the AI decide which one to recommend? The first thing is that when you open the recommendation page, the app will automatically detect the noise degree. And based on the noise degree, in different range of noise degree, we ranked the white noise and ambient temperature, as shown on the screen. So the less time it takes for a user to fall asleep, the better the white noise or the ambient temperature is. So based on the detected current noise degree, we go to the corresponding noise range and choose the white noise and temperature that are ranked at the top. And the second, yeah, and besides, we use the accelerometer to detect the ambient temperature. So the second originality is that the device would automatically fade out the white noise while it detects that the user has already fallen asleep. And it saves a lot of energy because when we use the white noise before, I learned that we can't just turn off the white noise when you're asleep. But for this device, it can fade out the white noise for you. So how could we detect the user is asleep? There's the sleep state detection, which is also accomplished by the accelerometer. So we use the accelerometer to detect the sleep state. If it hasn't detected the user's movement for about 20 minutes, then we determine that the user is already asleep. And here is a screen recording of the code running on the sorry. Here's the, yeah, you can see that here's a bed moved. So it's the code running on the accelerometer and the ESP32. So since the device is set on the bed, each signal saying bed moved represents a valid movement of the user. So I set a specific threshold for it to set it is bed moved. And the third originality is that there's no distraction for the user. Since the device is set at the side of the bed and it is really small, the length is just about the length of my thumb. Yeah, so it won't reduce the sleeping quality. And as shown on the picture, there's the design of my project. And the fourth originality is that there's a visualized report for the user to see their result. So the companion app provides historical data for users to identify patterns and adjust habit. So it will finally use the broken line graph to show that each day how many times it takes for the user to fall asleep. And for the future, as a high school senior, I decide to major in electrical engineering in the university and use advanced knowledge to implement my project. So the first thing I want to improve is the accuracy. So currently, I only use the bad movement to detect whether the user is asleep or not. So it's kind of not really accurate. So I will try to identify the breathing patterns and catch the threshold of people entering the sleep state. And I learned that while people fall asleep, their breath will become more stable and relaxed. But it's really hard to detect the breathing patterns only using the accelerometer and using the non-wearable device. So yeah, I'm looking forward to accomplish it one day in the future. And also, I'm trying to found a startup, but yeah, I'm currently just finding more friends who has the same interest with me. Yeah, and that's all. Please contact Sleepease if you are interested. And do you have any questions?